Imagine you're standing on a train platform. A train is coming, but this isn't just any train. This train is moving at 99% the speed of light. Now I want you to genuinely think about what you would see. Would it be a blur? A streak of light? Would you even see it at all before it passed? Here's the thing, the answer is so much stranger than you think. Not just a little strange, profoundly, brain-bending. Are you kidding me? Strange? Because at 99% the speed of light, the universe itself starts lying to you. Time warps, space shrinks, the colors of the stars shift, and the rules you grew up trusting, Newton's rules, your instincts, your gut, they all break down. So today, let's take a ride. Not in a science fiction spaceship, in the actual physics of our universe as best we understand it. Okay, first, let's make the number real. The speed of light is approximately 300,000 kilometers per second. You know what that means? In 1 second, light travels the distance from here to the moon and back almost 4 times. That's not a metaphor. That's a Tuesday for a photon. Now, 99% of that is about 297,000 kilometers per second. At that speed, you could circle the Earth's equator about 7.5 times in 1 second. I know it sounds made up, but stay with me because the numbers aren't the interesting part. The interesting part is what the universe does when something moves that fast. See, here's what most people get wrong about relativity. They think Einstein's big idea was that everything is relative, like it's some vague philosophical statement. But Einstein's actual insight was almost the opposite of that. He said, the speed of light is absolute. It never changes. For anyone. Ever? You're standing still? Light moves past you at 300,000 kilometers per second. You're flying in a rocket at 99% light speed, chasing a light beam. The light beam still moves away from you at 300,000 kilometers per second. Doesn't matter. Cannot change. The universe enforces this like a law with no exceptions. And that one stubborn fact about light is what bends everything else. Because if the speed of light is fixed, and speed is just distance divided by time, then when something moves very fast, space and time themselves have to flex to keep the math true. That's not poetry, that's what actually happens. So let's say you build your rocket. You get it up to 99% the speed of light. You've got a destination, let's say a star 10 light years away. Your friend is watching from Earth with a very powerful telescope. From your perspective inside the rocket, you feel totally normal. You drink your coffee, you read a book, nothing seems weird. But here's where it gets wild. At 99% the speed of light, time dilation kicks in hard. There's a formula for this called the Lorentz factor, and you don't need to memorize it. You just need to know what it does. At 99% light speed, your clock, your heartbeat, your aging, your biological processes runs about 7 times slower than the clocks back on Earth, so you make the 10 light-year trip. From Earth's perspective, it takes a little over 10 years. But on your ship, you've only experienced about 18 months. You land, you walk out. Your friend, who was your same age when you left, is 8 years older than you now. You didn't do anything special. You didn't take a magic pill or go into cryo sleep. You just moved fast, and the universe gave you a discount on time. Now, I want to be careful here, because this is where people often go wrong. They ask, but wait, from the rocket's perspective, isn't it Earth that was moving at 99% light speed? So shouldn't the person on Earth age slower? Ooh, that's a sharp question. I love that question. The answer is yes. During the trip, both observers see the other's clock running slow. That's the symmetry of motion. But the asymmetry comes from the fact that the rocket has to decelerate, turn around, and come back. There's a physical difference between the two paths through space-time. And when you account for that, when all the math settles, the traveler really has aged less. It's not an illusion. It's not a trick. It's measurable. It's real. We have actually confirmed this with atomic clocks on airplanes. The clocks on the plane run a tiny bit slower than the clocks on the ground. Exactly as predicted. Physics doesn't bluff, okay? So time bends. But it gets weirder. Space bends too. This one is called length contraction, and it is deeply uncomfortable for your intuitions. Here's what it means. When you're flying at 99% the speed of light, the distance between you and your destination doesn't just seem shorter. It is shorter in your reference frame. That 10 light-year journey to the star. From inside the rocket, you measure the distance as only about 1.4 light years. The universe, from your perspective, has physically compressed in the direction of your travel. The stars ahead of you are closer than they appear on any map. The stars behind you are farther away. Now imagine this scaled up. If you flew across the entire Milky Way galaxy, 100,000 light-years wide at 99% the speed of light, from inside your ship, it looks only about 14,000 light-years across. And if you pushed closer to the speed of light, say 99.9999%, the galaxy would compress to just a few hundred light-years.
At the absolute limit, the speed of light itself, the entire universe collapses to a single point in the direction of travel. Distance ceases to exist.
That's why photons, particles of light, experience no time and no distance. They are emitted and absorbed instantaneously from their own perspective. For a photon, the universe has no size and no duration. Think about that the next time you turn on a lamp. Now here's my favorite part. What would it actually look like? Not the math, not the equations. If you had a window in your 99% light-speed rocket and you looked out, what would you see? First, the stars would change color. This is because of the Doppler effect, the same reason an ambulance siren sounds higher as it approaches and lower as it drives away. Light does the same thing. Stars ahead of you. Their light is compressed into shorter wavelengths. It shifts blue, more ultraviolet, almost violent stars behind you. Their light stretches. It shifts red, deep infrared, fading at 99% light speed. The stars directly in your path would shift so far into UV that they'd become invisible to naked human eyes. And here's something even stranger. All the stars in the universe would appear to gather in front of you. This is called relativistic aberration, and it's real. At high speeds, light from all directions gets beamed forward. Stars that are normally spread across the whole sky behind you, beside you, they all seem to cluster into a shrinking circle directly ahead, like the universe is squeezing into a spotlight in front of your windshield. Behind you, absolute darkness, almost nothing. You would be flying into a compressed, blue-shifted, blazing disk of starlight with an infinite black void behind you. It's terrifying. It's beautiful. It's real physics. Now there's one more thing I have to mention, because people always ask about it. What about your mass? Here's the honest answer. In modern physics, we don't usually say mass increases with speed. That's old language. The more precise statement is that your momentum increases far beyond what Newton would predict. As you approach the speed of light, it takes more and more energy to accelerate you by the same amount. At 99% light speed, it would take about 7 times more energy to push you a little faster than Newton would calculate. At 99.999% light speed, about 700 times more energy. To reach exactly the speed of light with any object that has mass, you would need infinite energy. That's not an engineering problem. That's the universe saying, no. A hard, absolute, built into the laws of physics, no. So why does the universe have a speed limit at all? This is one of those questions where I have to be honest with you the way I think all science communicators should be. We don't fully know why in a deep philosophical sense, but here's what I find beautiful about it. The speed of light isn't just the speed of light specifically. It's the speed of causality itself. It's the speed at which cause and effect can travel. The maximum speed at which any information can move from one place to another. If that limit didn't exist, if you could move information infinitely fast, then cause and effect would break down. You could send a message into your own past. Causality would collapse. Time would have no direction. The speed of light isn't a speed limit like a highway sign. It's more fundamental than that. It's the clock rate of the universe. Everything we call physics, everything that happens, every interaction, every moment of time is built on top of this one constant. And the strange, beautiful, humbling thing is this. The universe is exactly weird enough to be interesting and exactly consistent enough to be understandable. Those two things together, weirdness and consistency, that's what makes science worth doing. So the next time you're outside at night, look up. Every photon hitting your eyes left a star thousands of years ago. It traveled the entire distance between you and that star, trillions of kilometers. And from its own perspective, it arrived the instant it left. No time, no distance. Just a direct line, stitched through space-time, connecting you to a star you'll never visit. That's not poetry. That's just physics.